Spend some time talking about part one of Lab 9 and what you need to know to be able to do that part. So, and again, that is merging CSV files. So, we are going to use the Pandas library to do this, which we've used in the past. So you should already have it downloaded, and you should be able to just import Pandas at the top of your programs. But if you need a review on how to download um, different like third-party libraries such as Pandas, I can put a link to their documentation in this week's module. But basically, we are going to use this module to do a few things for merging our CSV files. So we are going to first use the read CSV function, and that is what we are going to use to convert the CSV file into an easy to work with data frame. And basically, a data frame is a two-dimensional, you can manipulate the size of it, could be heterogeneous, so basically containing data of different types and sizes. Um, and it's a data structure with labeled axes for rows and columns. So you can think of it kind of like a X and Y axis like graph. Um, so a data frame is a two-dimensional data structure, um, and a pandas data frame consists of three components. And those components are the data, the rows, and the columns. So using this read CSV function is going to allow us to actually work with the data that is in the read CS or in our CSV files. It's going to allow us to actually work with that much easier. Um, and then the next function that we're going to use is concat, which is short for concatenation. And basically, concatenation is creating a series of elements together. Um, I think I mentioned concatenation when we were talking about strings. So you can concatenate strings, basically meaning you can put strings together to make a larger string. And this concat function in the pandas library is going to allow us to link values together along an axis of the data frame. So it's super nice because it does all of the heavy lifting of concatenation operations. Um, and that includes like performing set logic, like union and intersections, um, if that is required. Um, and we don't like manually have to do that. So that's super nice. Then we are going to call sort values to sort the values in a specific axis. Particularly, we are going to sort by the date column. So we want to sort we're going to merge our two CSV files, and then we want to sort them by date, so that it's in chronological order. And then lastly, we want to save that final data frame object to a CSV file, and that will be called our merged um, CSV file. So a sample bit of code that accomplishes this is right here. So step one involves loading the CSV files, which we have here. These two lines are doing that. So PD remember, is an alias for pandas. So let me, in our, like the top of our script, you've got import pandas as PD. And in theory, you could just omit the as PD and instead of saying PD, just write pandas. But it is convenient to only have to write two letters instead of six. Um, so that is where the PD is coming from. Just a reminder. Um, and we're using the read CSV function in the pandas library to convert our CSV file one by one to a data frame. So this first one we're calling data DF1, data frame one, and that is going to be our January sales data. And then the second one, DF2, is going to contain the data frame of our February sales data. And then next, we actually want to merge the files using, I guess at this point, we're merging the data frames. Um, we're going to merge them using the concat function, which is on line 3 here. And this is the syntax to do that within the parameters. So within those parentheses here of the concat function, we are saying that we want df1 and df2 to be concatenated together. And you have to specify that set within square brackets here. So the parentheses are for the function call itself, and then we want to give a set of data frames within the angled brackets here, or square brackets. And then once we have our merged data frame with both of our January and February sales data, we want to sort the values by date. Um, in place is a parameter that you can specify if you want that sorting to be done in the original data frame. Um, I guess you can in this example, you can in my version of Lab 9, I omit the in place argument there. So that's something that you could do, but you are definitely going to need the by argument to specify how you want it to be sorted. And we want to sort it by the date. So that is the third step. And then the fourth step, we want to save the merged file to a CSV. So, or I keep saying file, the merged data frame to a CSV file. And the arguments for that, we are giving it merged sales CSV, and that is going to be the name of the output CSV file. And this index equals false is not really necessary. It was just added there. But we definitely want to specify the name of our output CSV file. And that is part one, essentially. It's just 4 steps and could be done in as few as 5 lines of code, which is pretty nice. Um, and I can actually show you, let me get my, so this is an example of what I have for the lab. I didn't do the short form DF1, DF2. I was a little bit more explicit in my variable names because I just think it's easier to read and see what's happening. So I have January sales data frame, and that is what I'm reading the sales January 25 CSV and putting it in the Jan sales data frame, and then same thing for the February sales. And then I want to merge the data sets And I'm actually merging and sorting in the same line here, which is something you could do. Um, so I'm merging, and then you can call sort values on a data frame. So this here, pd.concat, these two data frames, gives me a data frame back. And then I can just call sort values on that data frame. And that in turn returns a data frame as well. So then all of this that's happening is being stored in the merged sales data frame. And then the last step is saving that data frame to a CSV file. And I actually do have index here. Um, right row names. Let's double check. Index, right row names. I don't want row names. So yeah, index equals false. We only really care about the um column names in this case, right? Like I think if we were to say index true for the row names, it would just give us like row 0, 1, 2, and we don't really care about that. We just care about the data itself. So that is why index is set equal to false. And we are saying that we want our final version of the merged data frames to be saved as merged sales. So if I run this, did I do that right? I want to run merge. There's my terminal here. There we go. So you'll notice, let me undo this RQ so you guys can see. Get rid of merged sales and do this one more again. So this is the script that you just saw, and I want to run merge.py, and it's going to take these two CSV files, merge them, sort by date, and then save as merged sales.csv. So we should see merged sales.csv show up here. And it indeed does. And now I've got January and February's sales all together. And I guess I could show you the individual files as well. So sales for January is right here. There's a missing product. No, yeah, there's a missing product name here. There's a missing quantity here. There's a missing quantity here. And then I think in February there was, yep, there's a missing revenue here. And I think there's also, yep, a missing quantity. So there are missing values so that we can actually do part two. And we do have a merged sales CSV file resulting from our merging script. So from here, I actually want, let me find here. So the next part of lab 2, or let me say that again. The next part of lab 9, part 2, involves cleaning the CSV files. So we're going to use the NumPy library for this, specifically the fill NA and drop NA functions. And the fill NA does exactly that. It is going to fill in values that are null or not a number or not valid. And then drop is going to drop rows or columns based on if the values are null or not. So the steps to clean the CSV file. We want to identify missing data. And we want to then fill in missing numeric values, replacing the missing values with the column's mean. And then we're going to drop missing product names. So any rows that have a missing product name, we're going to just drop that row from our data frame. And then once that data frame is filled and then dropped, we want to save the cleaned file to cleansales.csv. So these are basically the core of this part. We've got our merged data frame that we're working with. So before we do any of this, we are going to import our merged CSV file. I guess it depends if you want to do all of this within one Python file or if you want to do three separate Python files. Like I have in my directory, I have a clean, predict, and merge. It doesn't really matter that much to me. So if you are doing it like this, where you're separating the parts in different py files, then you're going to have to load the merged sales file like how we did for the merge part. So you're going to have to load them into a data frame, which we do here. And then we want to, let me scroll down here. Next, we want to strip the leading and trailing white spaces from column names. And this prevents issues like when I first was running this, I ran into an issue with it not recognizing or not being able to find the column names, revenue and quantity. And I think it was because I had a space after the comma in between values. And that was causing issues. So to solve that, you can ensure that there are no spaces between the comma separated values. But a good practice is to trim or strip the white space because if you had a much larger file, it's a lot harder to see where there could be like a space. So that is why I'm doing that. Um, and um, then I'm converting the revenue columns to numeric. Um, So if for whatever reason they were not being recognized as numeric values, then I am doing that here. I'm saying whatever is in the column revenue, I want them to be seen as numeric values. And depending on the data supplied, that will be either a float, so like a decimal, or an integer. Um, And the same thing happens with quantity. So revenue will likely be converted to float because it's like 22.0, whereas quantity is whole numbers. We're saying I want 12 whole cookies, and you can't really say I want 12 and a half cookies. Um, so that is going to ensure that we're working with numbers. And that will help us calculate the mean, which is down here. So we're going to, all of this is happening in one line. You can separate it in multiple lines, but this is how I did it. So I want my sales data within the quantity column. I want to fill any null or nan values with the mean of the quantity column. So let me break this down. Can I please? Oh, okay. So I am saying that within the quantity column of my sales data frame, I want to fill any NaN or null values, specifically with the mean of all of the items in the quantity column. So, so the quantity column is going to get its mean calculated here, and then that value is going to be used to fill any of the missing spaces within the quantity column. And the same syntax is repeated just for the revenue column here. And then lastly, we want to remove any rows that are missing a product name. So if there is a row that does not have a product name, we're going to drop that row and then update our data frame to represent that the data frame with the freshly dropped rows. And lastly, we want to save that resulting data frame to a clean sales.csv. And notice I'm also adding a print statement at the end of my scripts, just so that I get some output in my console here. Um, but you don't necessarily have to do that. It's just something that I like to do to make sure that a script has been fully completed. And then let me run let me run this. Um, and clean. If I run this, please. What's happening? Oh no, that's from stop. There we go. Jeez Louise, it kept getting stuck. So now on the left side of my screen in my Explorer, there is a clean sales CSV, and it looks like those missing values were replaced with the mean, which we could clean that up a skosh. We could say, oh, we want the mean, but only up to the second decimal point. Um, you could do that if you want. Um, I think we did that in a previous lab. Um, and then it also removed the rows that had missing product names. So there was one from the February sales and one from the January sales. So that leaves us with 18 items. So that makes sense. That seems right. And then let me go to the last part here, which is predicting values in a CSV file with machine learning. So to do that, we're gonna spend some time talking about linear regression. This is not something that I'm going to test you guys on. This is just a technique for prediction. And I think it's just nifty to know. Um, I think having this kind of knowledge sets you apart from um, any other old applicant for jobs. Having machine learning knowledge is very valuable nowadays. So that's why I'm taking the time to teach this to you guys. But I don't expect you to fully grasp exactly why things are happening or all the math because a lot of it is just math, but that's why Python exists and Python libraries exist so that we don't have to worry about that. Um, so what is linear regression and why are we using linear regression? So imagine that you own a small business, like my bakery business, and you notice that uh, the more items people buy, like in terms of quantity, then the more money they spend, revenue, which is the revenue value. So that makes sense, right? The more items people buy, the more money they spend. That tracks. So you want to predict future revenue based on your past sales. That's a perfectly valid reason to explore these options. So linear regression is going to help us find a relationship between two things, in this case, quantity and revenue, and then use that relationship to predict missing or future values from our data sets. And as we mentioned, revenue is dependent upon quantity, and revenue is equal to M times quantity plus B. So does that equation look familiar? It should, assuming you took algebra at some point. Um, it's the slope, y equals mx plus b. And linear regression is basically just finding a straight line equation that best fits the data. So the general equation of a line, as you guys know, if you've taken any algebra class, is y equals mx plus b, where y specifically is what we're predicting, x is what we know. Here, let me write things down actually. So y is, let me do this in one word. Y is our prediction. I'm sorry, X is the thing that we know. And M is the slope. In other words, it is how much revenue increases per quantity. And then B is the y-intercept. Um, y-intercept. Um, and the starting point, uh, basically the starting point when the quantity is zero. So when the quantity is zero, then you can't really charge someone for something that is zero. So zero is our y-intercept in this case. Go to the next page, please. Thank you. So we're going to visualize this concept a bit. So if we plot past sales data with a simplified version, we're not going to use the CSV files we've been using. We're just using a simplified version where our revenue is on our y-axis and our quantity is on our x-axis. And we are going to say, we're just going to look at quantities 1 through 4. So I'm going to put 4 tick marks here. I'm going to say for quantities of 1, 2, 1, 2, 3, and 4. And then for revenue, we're going to say something pretty simple like when the quantity of 1 is at 10, a revenue of 10. If you're getting 2 of an item, it is 20 for revenue. 3, oh, sorry, I can't see where my dot lines are. There we go. So 3 of an item gives you a revenue of 30, and 4 of an item gives you a revenue of 40. So we can use our eyeballs, and we're all smart people. And I guess I can say 0 is at 0. We're all smart people. We can see that this creates a straight line. I'm trying my darndest to create a straight line. Um, and we can notice a pattern that revenue is always 10 times the quantity. So our equation for this is revenue, which is what we're trying to predict, is equal to 10 times the quantity, which I'm just going to shorten with Q. And I'm not even going to include the plus 0 because that's nothing. Plus 0 is nothing. So that is the equation that we are using. Um, and if we suddenly don't have revenue for some quantity values, we can just use this equation to predict them. So from here, so that simplified idea of predicting using a linear equation um, will take us into predicting values with linear regression. So it's just drawing the best fit straight line to predict values. And it can help us estimate um, our missing values within using patterns within the data. And there is a handy dandy library called scikit-learn that does all of the math for us. We were given a very simplified example previously with whole numbers and didn't have to do much math. But not all numbers are super cute and pretty, so it's gonna be nice to have scikit-learn to do all the math for us. Um, but the steps to do the actual predicting with linear regression goes like this. So there is going to be a step where we are going to split the data set into a training data set and a testing data set. And then from there, and by the way, the scikit-learn module has all of the functions to do this. So there's very minimal logic for us to have to suss out, which is amazing. So then we're going to train our model using the existing data. And then from that trained model, we're going to be able to predict missing values. And then once we have some predicted values put into our data frame, we can save that to a new CSV file with predicted sales. So this is a script to train our model. So to train our model, we have to load a data set. The data set I want you guys to use for this part is the cleaned sales. So we are going to separate our rows with and without missing revenue. So our known data is going to contain items in our revenue column that are not null. So things that we actually know. There's actually values in the positions of our revenue column. Then our missing data is going to contain any item within the revenue column that is null. And then we want to prepare our features X and our target Y. So X is both of these are going to be from our known data because we're training with what we know. And then we're going to use the missing data later to actually fill in based on our predictions. So we're going to get the known data from our quantity. column, which is going to be our X. And then our Y, we're targeting revenue here. So we want all of the known data within the revenue column. And then lastly here for training, we want to train a linear regression model. So all I'm doing for that is saying I want to create a variable called model, and I'm calling the linear regression constructor from the scikit-learn library. And this is going to give us a model, specifically a linear regression model. And then I can just call model.fit on the features and target data, and it will train the model. Then we have our trained model. And next we want to use that to predict and update our missing revenue. So we're going to check if missing data is not empty. And if that returns true, then we want to use our model to predict. So you can call the predict function using our model. And we are going to use it specifically to predict missing data or predict the quantity from oh my gosh, this is tripping me up. Sorry. We want to find our goal is to find the missing revenue. That is what we are trying to predict. But in order to predict something, we need some data to go off of. So we are giving our prediction function call the missing data from our quantity column. And our model is trained to, we'll see how good it actually is, but it is trained to do some kind of prediction based on this missing quantity data. And then we're going to update the original data set, conveniently using the update function. And we're going to update based on our missing data and store that in our sales data frame, which is what we've been using. Sorry, I have to switch from pen to cursor. That's what we've been using as our data set. So then we've updated the original data set, and we want to save it as we have been for the last couple parts. So we're saving that to a predicted sales.csv file and then saying that we have done the thing. I'll show you, this is my predict function or my predict script. So I am loading that file of the cleaned sales. I'm separating my known and missing data from the revenue column. I am going to prepare my features from the quantity column, and then my target, which is revenue, train my model, and then predict the missing revenue values using my trained model, update the sales data frame, and then save that data frame to a CSV file by calling it predicted sales.csv.